There are two types of memory location. One is static memory allocation, so another is dynamic memory allocation. In static memory allocation, the memory to be allocated is pre-known and it is done during the compilation itself. For example, integer is equal to some 10, some variable you decide. So that is how we are going to assign during the compilation itself. That is, it is done during the compilation. So that's why we said it's a pre-known, the amount of space is required, and then depending on the requirement during the compilation itself, it allocates those sufficient of memory space. So another type of memory allocation is dynamic memory allocation. So in dynamic memory allocation, the amount of memory to be allocated and it is not known, and it is done during the runtime as in when it is required. To do this, C++ supports dynamic memory allocation and deallocation of objects using the new and delete operators. So these operators allocate memory for objects from a pool of memory called free store. So we can allocate memory for variable while program is running using a new operator. So it is possible to create a memory space without defining variable. That is possible by using pointers. So we can make a memory space from free storage and its address copy to the pointer. So using the pointer indirect operator, we can perform all the operation on that memory storage. So that is, we'll take with example. To allocate memory using new operator, so there is a general syntax you can notice there. So pointer variable name followed by assignment operator followed by the function new and followed by data type. So data type defines what type of dynamic memory, that space is required, that will be allocated, and it gives its address. That address can be copied to the pointer. So that's, you can see there. So we have a variable pointer p and new followed by integer. So that's, you can see this diagram. So there is a memory is allocated which has address 6550. So that 6550 is copied to the p. So this is done automatically when using new operator. So now I can use a star p to use the content on that memory location. That is what indirect operator already we have discussed. So similarly for other data type, any data type, so I took your integer, similarly it can be float, similarly it can be an array also, or it can be a structure also, or it can be class object. We'll discuss all this in the next, we have a next example. So let us learn this concept. One more important of this a pointer is, that's a dynamic memory allocation, is normally when we exit from the function, so the variable will be destroyed, because this is done during the execution of program. So even we quit and re-enter, so this pointer is not destroyed. So it will be retaining the address, that is the value remains occupied even we exit from the function. So we'll take an example to illustrate this. So we can see there, just I've used only one header file, so iostream.h. There may be many other also. For simple understanding, I've wrote this. There are many maybe. So you can see there, so I have declared a pointer of type integer as a global variable. So what is the use of this global variable means they can be used in the subprogram, that is in the function as well as in the main function. So let us take some function which neither receives nor return, a simple function fun, and then you can see there is a dynamic memory of type int, that is integer memory is created and that address is copied to p. So in the star p, in that address we copy the value 25. So and then we exit the function, we will come back and we display the value stored at p, that address is star p 25. So now this is displaying 25. So there is no variable I have declared. There is no but I declared pointers, but I am not declared any variable. But the space is we obtain dynamically, that is using new operator. That's why we exit from the function and still we have the value, that space is not destroyed. So that's the advantages of dynamic memory allocation. So after completion, after quit exit from the function, and again that memory is not destroyed, that remains occupied. So that is the something about dynamic memory allocation. So you can see the example. Okay. So once it is dynamically allocated, so it has to be deleted or it has to be deallocation. So it had to be deallocated to perform these operations. So we use a delete operator. So it is used to deallocate the memory which was allocated using new operator. So it frees the memory back to the free store. So look at the syntax. So delete, we have a pointer name. You can see the example. So delete followed by pointer name. So delete P. So that deletes, that frees the memory and back to the free store. So if it's an array, so you have to mention the size and pointer, that's pointing to array. Similar for structures, similar for classes and objects. So this is something about delete operator. So now let us discuss the difference between a static allocation of memory and dynamic allocation of memory. So let us learn static allocation means already we know. So it is done during the compilation, and then this is also remain active throughout the program, and also they are implemented using stacks and heaps. Let us we go with one by one. So I think it is better to explain with the points, key points, then you will understand exactly what it is. Okay, a static memory allocation. The memory is allocated before the execution of program begins, that is during the compilation. So most of the variables which have this so far we have declared, they have done under static memory allocation. And second point, static memory allocation is no memory allocation or deallocations are performed during the execution. That is, nothing is done during the execution. So memory is required, is already pre-known and it is declared, and just we use them. So that's therefore we do not have memory allocation or deallocations are performed during execution. So next one is these variables remain permanently allocated, because before the program begins, during the compilation itself, the memories are created. They remain active throughout the program. So that is a one more, and they are implemented using stacks and heaps. Already we have discussed stack linear data structures, and heap is also data structure, but we are not studying this academic. So they are implemented. How this static memory allocation is executed inside the computer means that is using stacks and heaps. So now look at the dynamic allocation of memory. So memory is allocated during the execution of program, as we know that. So during the program is executed, we needed memory means then it has to be done using dynamic memory allocation. So next was memory binding are established and destroyed during the execution. That is the example of memory allocation and deallocation. Binding of memory established, and after its usage it has to be destroyed. So this is done during the execution of program, which is not found in static memory allocation. So allocated only when the program unit is active. So whenever we wanted variable memory space, only that time the memory is active, that is memory is created. Otherwise it is not permanently allocated. But in programs, what we call static, once you define whether you use it or not, that will be active throughout the program. So they are implemented using data segments. So these dynamic memory allocation are implemented using data segments. So these are the differences between static and dynamic memory allocation. So pre-store or heap memory. So already I've explained the pre-store. So whenever memory has to be allocated dynamically, from where this memory space are obtained, that is from the heap memory or pre-store. So what is this pre-store? Is a pool, pool of unallocated memory heap given to the program that is used by the program for dynamic memory allocation. So that is what we call as a free store. So this is normally operating system keeps certain amount of memory as a free store or as like a heap memory. So this is normally used for dynamic allocation of memory during the program execution. So that is something about free store or heap memory. This also sometimes known as availability list or free list. Okay. So next we learn something about called memory leak. So what is this memory leak means? Already we have understood. So whenever memory is allocated dynamically and if you are not deleted using delete function, so these memory locations or memory blocks remain occupied even at the end of the program. Such memory blocks are known as orphaned memory blocks. You can see there is a word orphan because no program is taking care, so nobody is using that one. So it is like orphan. So such memory, when increase in number, so they bring adverse effect on system. So this situation is called memory leak. So whenever we create a program with a dynamic memory allocation, so after its usage is over, if you are not deallocated using delete operator, they remains active in the program, so thereby making adverse effect because that memory we cannot use for other purpose. They remain occupied. Even nobody is using that part of the memory, but still it is occupied. So therefore, when this type of orphan memory increases, they bring adverse effect. So that situation is called as memory leak. So we learn one more important concept of pointer is a self-referential structure. So what does self-referential structure means? So it's a structure that contains one of its member which is a pointer pointing to another structure of the same type. You can see here we have a node structure with two members and we have a node 2 structure with two members. They are same type of structures. But structure 1 contains a field that will be containing the address of another structure. So that structure is called as a self-referential structure. You can see here, so this structure node 1 contains address field which is a pointer which is pointing to the another structure is also of same type. So such structures are called self-referential structures. So this will be discussed in detail when we talk about the linked list. So that's one of the linear data structure. We will discuss that one.